Okay. Let's move on the last example based on your block reduction method. The example is little bit complicated as you see, but it is simple one. See how they confuse us. Initially they are giving us mixer. Okay. Again 3 blocks are there. Okay. It is like this. Okay. Then all blocks are mixed together at a single mixer like this. Okay. Again there is a second mixer. 3 blocks are again in this position. See, this is connected here directly, this is connected here directly, and this is feedback connected here. Okay, and again there is a mixer like this. Okay, and this block is connected from here. Okay, and at last again there are 2 blocks in parallel. Okay, and it is like this. Okay, it is came from here. See, this is the G1 block, G2 block, G3 block, right? This is the G4, this is the G5, and this is the H1, right? This is the G6, and this is the H2, and last one is G7. This is the G7. Okay, G7. Okay, see, this is the block, and one more feedback is there, overall feedback, that is H3. Okay, maybe you think that this is the most difficult numerical because there are number of blocks available. What to do, because there are more blocks are, see, 1 2 3 4 5 6 7 8 9 10 11 blocks are there. What to do? Just don't worry, just use our basic formula, step by step you get the solution. So what is the first step? See, we put this mixer as it is. Okay, this mixer as it is, right? Now G1, G2, G3, all 3 are in series, right? And what is the sign conventional? All are positive. See, this is positive, this is positive, this is positive. So we use parallel rule. So what is the parallel rule? G1 plus G2 plus G3. Just see a rule number 2 combination in parallel. So it become like this. Okay. Now next mixer. Again see, we put as it is, this one we put as it is. Okay, can we do one thing here? For this here we use the rule number 2, that is parallel combination, right? Can we do here? See, this shifting is the takeoff point, right? Can we shift this takeoff point here after the block? Okay, takeoff point after the block, that means rule number takeoff point after the block, rule number 5. When we shift takeoff point after the block, it become division, right? So just shift this takeoff point. So this is G4. Okay, and this is as it is. Okay, when we shift this takeoff point after the block, it become, okay, I'm just taking this mix a little bit here. Okay, when we shift this takeoff point after the block, what happen? It becomes G5 divided by G4, right? And we give here, right? This is positive, and this feedback is again as it is, that is H1. Okay, this is as it is, right? Now see, can we use here like this? Can we use like this? Elimination of feedback rule. So elimination of feedback rule is as it is. So what is the elimination of feedback rule? It is the G6 divided by 1. It is in positive side, right? So it is 1 plus G6H2, right? And last block G6 is as it is G6. One second, I have a very little space here, that's why I'm little bit okay. And this feedback is came from here towards the input side. This is H3. Okay, see, in the first step only we are doing 3 steps combined. We are merge this G1, G2, G3 in parallel combination. We just shift this takeoff point after the G4 block, and we use here elimination of feedback rule, right? Let's move on the next step. What is the next step? Okay, what will be the next step? See, after this, can we do this combination, elimination of feedback rule again? Elimination of feedback rule here, and again this is the parallel path. Just consider here 1. Okay, so this mixer as it is. Okay, then G1 plus G2 plus G3. Okay, then see, elimination of feedback path. What is the rule? G4 divided by 1 plus, because it is minus here, so it becomes plus G4. Once again I make it clearly. Okay, elimination of feedback rule, right? So what is the elimination of feedback rule? G4 divided by 1 plus G4 H1, right? Next one is again this parallel combination, so it become 1 plus G5 upon G4, right? Okay, again the next one is as it is. What is that? It is G6 divided by 1 plus G6H2, right? And one more block is there, and just drop this block here, G6. Okay, and now from that we get feedback, that is H2. Okay, just understand guys, understand brother here, because I have a little space, so that's why. Okay, this is connected. Okay, now see, all these 5 blocks, 1, 2, 3, 4, 5, all these 5 blocks are in series. Okay, so what is the series rule said us? Series rule is very much simple. Once all blocks are in series, we put in the multiplication form. Just put everything in multiplication form. So first G1 plus G2 plus G3 as it is, G4 divided by 1 plus G4 H1 as it is, into 1 plus G5 upon G4. Or can we put like this? Just take cross multiplication. So G4 plus G5 divided by G4, right? And next block is G6 divided by 1 plus G6H2, and last one is G6. So this is your block. This is your block after making all in multiplication. Okay, and this is feedback element, that is H3. Okay, what will be the next step? What will be the next step? Again, elimination of feedback rule. Elimination of feedback rule is very much simple. Forward path is very much longer, bigger, divided by 1 plus forward path into feedback element. Let's start. Forward path, that is G1 plus G2 plus G3 into G4 divided by 1 plus G4 H1. Okay, then G4 plus G5 divided by G4. Okay, G6 divided by 1 plus G6H2 into G6. Okay, whole divided by G1 plus forward block, that is again G1, G2, second region plus now, positive G2, positive G3, then G4, 1 plus G4 H1, then G4 plus G5 divided by G4, right? Then G6 divided by 1 plus G6 H2, right? And G6 into feedback element. What is the feedback element? H3. H3. Okay, this is the single block we get after calculation. Okay, this block we can put as it is because there is nothing to reduce, so just put it as it is. Or if you want to reduce it, you can reduce it using our normal or regular method. Okay, just cross multiply, we get a final answer. Just cut it everything, you get the final answer. Okay, this is your final example from block reduction method. So here we finish our block reduction method. But if you have more example based on your homework or based on your assignment, please send it that homework. I will provide you a solution of the block reduction method numericals. Okay, thank you.